Okay, so we'll just kind of start by recalling what we did in first year, and now we're in second year probability. But if we just start by saying how we list possible outcomes from given events, if we recall from probability we have these trials like tossing a coin or throwing a dice, and out of these trials are possible outcomes. Some outcomes we want, they're the events, and we look to desired results or events, so we look to see the probability of these events happening. Okay, but first of all, we'll just go back to listing, how we list possible outcomes. So a car manufacturer produces different types of cars as follows. So the model can come in three types, three ways: saloon, estate, and hatchback. The colours, three different colours, and three different types: standard, deluxe, and premium. How many different choices of car does the buyer have? Well, the number of possible outcomes are the three: saloon, estate, hatchback, by the three colours, by the standard, deluxe, premium. So there's 27 different types of cars, and we've learned how to work out the number of possible outcomes by applying the fundamental principle of counting. Okay, and if we were to list, the different models, like the saloon, which is silver standard, or the saloon, which is silver deluxe, saloon silver premium, and so on, to list all the cars, that would be to list the sample space. And we also met with, say, chance and the probability scale. If we recall, that probability goes from 0 to 1. Halfway is evens chance. 0 is impossible, probability of something likely to happen. 1 is certain, and we have unlikely, likely, and evens chance. Okay, so the more likely an event is to happen, the closer the probability of it happening is to 1. We'll just look at an example here. The jar contains red, blue, and green marbles. Mark the probability scale for the chance of taking each colour out of the jar. So the probability of getting a red, well, there's 3 reds there in the jar, is 0.3. So we'd mark that at 0, 0.5, 0.1, 0.2, we'd mark it there. Of getting a blue, there's 5 blues, 1, 2, 3, 4, 5. So that's 0.5, so that goes halfway up the scale. And a green, then, there's 2, or 1 and 5, 0.2. The green would be marked there on the probability scale. Okay, and we'll just go back to, we'll just recall that probability and the whole notion of equally likely outcomes. And last year we worked with the formula for equally likely outcomes from a trial. The event, the probability of the event, or the desired result we were looking for, was equal to the number of favourable outcomes divided by the number of possible outcomes, all listed, as listed in the sample space. Okay, so just so we could just, before we move on, we can find probabilities for certain events, simply using we plot we would plot possible outcomes, and we plot that on the scale. Okay, but the number of favourable outcomes, that refers to this, is the number of times the what we want, the event, the desired results, how many times that appears in here. So we did this in first year, we're just going kind of refreshing it for now. So let's look at some worked examples then. A card is chosen from a pack of 52 playing cards. What's the probability that the card will be a diamond? Well, there's 13 diamonds in the packs, 1 and 4. Probability that a card pulled will be red. There's 26 red cards. If you consider the diamonds and the hearts, of 52 is 1 and 2. Of black, again, there's clubs and spades, 13 of each, 26 in total, that's 1 and 2 again. Probability has 4 suits cards, each has a 3 in it, so it's 4 over 52, it's 1 and 13. And the probability that it's a picture, well, there's ace, king, Jack, Queen, King, times 4 gives us 12, so it's 12 and 52. And then the probability that it's an ace or a king, well, we've 4 aces and 4 kings, so in total that's 8 out of 52, it's 2 out of 13. Now, let's look at this example. Of 100 tickets sold in a raffle, Luke bought 10, Heather 5, Alan 1. A ticket was chosen at random to see who'd win. What's the probability that Alan would win? Well, Alan bought one ticket in 100, so his probability of winning is 0.01. Luke bought 10, so his probability of winning is higher, it's at 0.1. Heather bought 5, so she's a 1 in 20 chance, so her probability of winning is 0.05. And the probability that none of the above win anything would mean the remaining amount of tickets bought by other people would be 84 over 100, be 0.84. And if you note that 1 minus 0.84 is equal to the sum of these other three possibilities here. Okay, all the probabilities add up to 1. Okay, how many of the 100 tickets would I need to buy for the probability of winning to be 3 in 10? Well, the way to do this is to equate 3 in 10 is equal to the number divided by 100, and if we cross multiply, we'll get 300 equals 10 times number, or number equals 300 divided by 10. You'd need to buy 30 tickets to give yourself a chance of 3 in 10 of winning. To give yourself a chance of 0.2, we just equate 0.2 equal to the number over 100, and cross multiplying again, we would find that we'd need to buy 20 tickets to give yourself a 0.2 chance. And to give yourself a 25% chance, again, we equate and cross multiply, you'd need to buy 25 tickets. And finally, to give yourself a 100% chance, then we would equate 100 over 100 and multiply that by, equate that to a number over 100, and if we cross multiply, we find that we would need to buy 100 tickets to give yourself a 100% chance of winning. Okay, a game is played by picking a card at random from a pack of 52. Okay, and this table shows the results of picking various cards. So if you pick an ace, you win €2. King, queen, or jack, 50 cents. 6, 7, 8, 9, 10, no result. 2, 3, 4, 5, and you lose 50 cents. If Ellen find out the probability, if Ellen picks that she'll lose, the probability that she'll lose is given by if she picks a 2, 3, 4, or 5 from any of the suits. That's 16 cards, 4 over 13. That she'll win, well, it's a win if she picks any of these 4 cards from the 4 suits, so 16 cards again are winning cards out of 52, it's 4 over 13, same chance. That she'll neither win nor lose, so it's these cards here multiplied, 5 cards multiplied 4 is 20, and the probability that she won't lose. Okay, so if she doesn't lose, then it's all of these cards multiplied by the 4 suits, and that gives us 36 out of 52 is 9 out of 13. This 36 from the fact that we've 9 no-lose cards by 4 is 36.